We're back for lecture video for Preboard 1. This time, let's answer the problem set for solid geometry. Now, let's start with number 1. If the edge of a cube is increased by 30%, by how much is the surface area increased? A. 67%, B. 69%, C. 63%, or D. 65%. Now, let's have a comparison. So, it has two situations. First is the original surface area of the cube. So, let's say, let A1 as the original surface area of the cube. Okay? And then, let's have a sub 2 as the increased surface area of the cube. Then we have the x1 as the original side, measurement the side, and then the x2 as the increased measurement of the side. Okay, so what happens here is that for x2, the increased measurement of the side of the cube is that it increased by 30%. So it is x1 plus the 30% of x1. Therefore, x2 is 1.3 x sub 1. Now, since we are dealing with similar cubes here, since similar cubes, like similar triangle theorem. Now, let's have the area. We're comparing the area 1 to area 2. That is equal to the side of x1 over x2. And let's square that because we're dealing with area. Okay, therefore, we have here a sub 1 over a sub 2 equals x sub 1 squared all over x2 is 1.3 x1 squared. Okay? Then we will be dealing with the cross multiplication. So we have here a2 x1 squared, that is equal to, so what is square of 1.3? That is 1.69 x1 squared a1. So we will cancel out here x1 squared. So what's left is a2 is equal to 1.69 a1. That means for a2 is equal to a1 plus 0.69 of a1. So what is 0.69 here? That is increased by 69%. So the answer for number 1 here is letter B. Okay, so that's for number 1. Let's go for number 2. A right circular cone with an altitude of 8 centimeters is divided into 2 segments. So how is it divided? One is a smaller circular cone having the same vertex with volume equal to 1/4 of the original cone. Find the altitude of the smaller cone. So it means it is a cone and then divided, it's not vertically, but it is divided horizontally because it says there is a smaller circular cone. So that's the idea there. So what is the altitude of this smaller cone? That is letter A, 4.52 centimeters, B, 6.74 centimeters, C, 5.04 centimeters, or D, 6.12 centimeters. So let's have the figure. There you go. That is the right circular cone with an altitude of 8 centimeters. So let's have the altitude here as 8 centimeters. Okay, so And then we're looking for the altitude of this smaller cone. So that means this one here. This is 8 centimeters, and let's name this as H. Okay? And it says there the volume. The volume of the smaller cone is equal to the so it's here, volume equal to 1/4 of the original cone. So meaning if we put here V sub O as the original cone and then the VS as the smaller cone, therefore the VS here is 1/4 of V sub O. Since we're dealing with similar cones, so similar cones, and we're talking about volumes, so let's compare the volumes. V sub O, V sub S is equal to the same altitude. So we have there 8 and H for the S. And this is raised to the power of 3. Okay, so make sure this is for the smaller cone and this one here is for the bigger cone. So V sub O all over 1/4 of V sub O is equal to 512 all over H raised to 3. Cancel V sub O here. Therefore, H raised to 3 is equal to, what is 512 divided by 4? 128. Therefore, H is equal to 128 raised to 1/3. So that is 5.04 centimeters. So the correct answer here is letter C. 5.04 centimeters. Let's go to number 3. A truncated prism has a horizontal triangular base ABC, where AB is equal to 10 centimeters, BC is equal to 12 centimeters, CA is equal to 8 centimeters. The vertical edges through A, B, and C are 20 centimeters, 12 centimeters, and 18 centimeters long, respectively. Determine the volume of the prism in cubic centimeters. Letter A, 661. Letter B, 559. Letter C, 685. Or letter D, 574. Okay, so it's a truncated prism. Let's see the figure. So here is the figure of the truncated prism here. So the base here, ABC, has the measurements. So here's the ABC here. ABC, that's the base. With measurement AB, 10 centimeters. Then we have BC as 12 centimeters. CA as 8 centimeters. Then says there vertical edges. So we're talking about the vertical edges. Through A, B, and C, they are 20 centimeters, 12 centimeters, and 18 centimeters long. Then it's asking for the volume of this prism. So we need to find the volume of this prism. To find the volume of the prism, truncated prism, we need this formula. Volume is equal to A sub B, or that is area of the base, multiplied by summation of H. Summation of H means the summation of the sides, the vertical sides. So the 18, 20, and 12. Then N is the number of sides of the base. Okay? Then for us to solve for these, we have the base, area of the base, we need to solve that because we already have the summation of h and n. So we need to solve for the area of the base using Hero's formula. A sub b is equal to square root of s multiplied with s minus a, s minus b, s minus c, where s is a plus b plus c divided by 3. Now this is talking about the base. So for s, we have it as, let's just put here. So s is equal to a, let's say that is, let's just put it 12 plus 8 plus 10 divided by, oh, it should be divided by 2, sorry. Okay, divided by 2. So that is 12 plus 10, that is 22 plus 8, that is 30 divided by 2, that is 15. 15, therefore a sub b, so a sub b is equal to square root of 15 times 15 minus 12, 15 minus 10, 15 minus 8, so square root. And then a sub b is equal to 15 square root of 7. Therefore, we now have volume is equal to 15 square root of 7 times 20 plus 12 plus 8 divide 18. Should be 18, sorry. 18 divided by 3 because of the number of sides of the base. Okay? So that is equal to, so volume is equal to 661.44 cubic centimeters. So from the choices, the nearest answer here is letter A, 661. Okay, so that's for number 3. Let's go to number 4. Find the volume of a cone to be constructed from a sector having a diameter of 72 centimeters and a central angle of 210 degrees. Letter A, 12,367.2 cubic centimeters. B, 13,232.6 cubic centimeters. C, 13,503.4 cubic centimeters. D, 14,682.5 cubic centimeters. So there is a cone to be constructed from a sector having a diameter of 72, then central angle of 210. Of course, we're talking about here circle. Okay, drawing a circle here. Now, a sector is a part of the circle. So, the one that we are going to make into a cone here is the blue curve here. It's the blue curve. That's the 210. So, that's the 210 degrees sector. So, we have here as C1 as circumference of the circle, the whole circle. C2 as the circumference of the base of the cone. So we have here the C2. And then C is the length of the arc. Okay, so the length of the arc here. Then we have here the radius, because the given in the problem is diameter of 72 centimeters. So we put here the radius as 72 divided by 2, and that is equal to 36. Okay? So take note, this is the one to be made into a cone. Okay. So the one to be made into a cone. So that means that C2 here is actually the circumference here. The circumference of the cone. Okay, CC. Right? So, let's solve for the... So, how do we solve this if we are looking for the volume of the cone? Now, the volume of the cone is... The formula for the volume of the cone is equal to 1/3. So, this cone here. 1/3 pi. So, pi r squared, but since we put here x, so let's use x. Pi x squared, and then the altitude of the cone, h. So, what we're missing here is the value of x and the value of h. So, how do we find the value of x and h? Okay. So, let's do some comparison. C, or the circumference of okay, let's put here C2 as the circumference of the base of the cone is equal to the C1, circumference of the whole circle, minus C, the length of the arc. Okay. So, let's find the formula for C2. So, the C2 here, the CC or the C2 is the circumference of the base of the cone. So, let's have it as 2 pi r or 2 pi x because the radius of the base here is x. 2 pi x is equal to C1 circumference of the circle. So, that is the 2 pi r. So, look at the difference. This is bigger because we're using the radius of the circle, and then this one is smaller because we're using the radius of the base of the cone. Minus, how about the length of an arc? That is r theta. So, r theta. That is 2 pi x equals 2 pi r. Radius here is 36. Minus radius of 36. And then, what is the theta here? Theta is 360 degrees minus 210. So, that is 150 degrees. So, it's 150 degrees. Convert that into radian. So, multiply with 2 pi divided by 360 degrees. So, we now have 2 pi x equals... so, this is actually cancellation. Cancellation here. Just cancel out here 2 pi. It's already cancelled. Is 2 pi. So, what's left here is x is equal to 36 minus, so we have here also 15. Okay, therefore x is equal to 21 centimeters. Okay, so we got the value of x already. Now, missing is the value of h. For the value of h, let's look at this figure here. So, what we can see there is the Pythagorean theorem as r being the hypotenuse equals h squared plus x squared. So, r is 36, or let's just arrange this as h squared equals, or let's have it as h equals the square root of r squared minus x squared. Okay? And then, that is h is equal to square root of 36 squared minus 21 squared. So, h is now equal to 29.24 centimeters. Therefore, since we finally have the values for x and h, volume now is equal to 1/3 pi x squared is 21 squared times h, 29.24. So volume now is equal to 13,503. Okay, it's 503.44 cubic centimeters. So 13,503.4, that is letter C. The answer for number 4 is letter C. Okay, so that's for number 4. And now let's go to number 5. A solid rectangular parallelepiped, or its parallelepiped, measures 5 centimeters by 6 centimeters by 8 centimeters and is painted blue completely. It is cut through parallel planes to form cubes, 1 centimeter on a side. Determine the number of cubes with 2 faces painted. Okay? So, how many cubes of size 1 centimeter on one side which have 2 faces painted? Okay? Is it A, 16, B, 52, C, 8, or D, 72? Okay, so parallelepiped definition. A rectangular parallelepiped, which is it in the problem. So rectangular parallelepiped is a 3-dimensional structure whose all the 6 faces are in a rectangular shape and the length of the parallel edges are equal. Okay, so it's a rectangular prism. Rectangular parallelepiped. Okay, so the dimensions are 5 centimeters by 6 centimeters by 8 centimeters. And it's looking for the number of cubes, 1 centimeter on a side, which are painted only on 2 faces. So if we cut this, prism here, the cubes, if this is all painted blue, the cubes that we are looking for will be located at where? Wherein there's 2 faces painted. So we will be having it here. Oops. We cut it here. There, we got it here. Okay. So we will get the cubes there. But the problem here is the edge, the corner will have 3 faces painted. So we will remove the cubes in the corner. So let's mark all those areas where we can find the cubes with 2 faces painted. Right? So there you go. So these are the areas with cubes, 2 faces painted. Right? And then we will be removing the corners. The corner here, corner cubes, these are removed. So what's left now, where we can locate the cubes are on this location. So by visual inspection, what happens here is that the location of the cube with two faces painted, if we are looking at this part here, the dimension there is 5 centimeters minus, so one cube is 1 centimeters, right? So this is 1 and then 1. So what happens here is the one we're looking for becomes 3 centimeters. This part here becomes 6 centimeters. Then here we have it as 4 centimeters. That's why by visual inspection, if we are to cut the cubes in this portion here at 3 centimeters, how many? We have it 1, 2, 3, 4. 4 areas. So 4 times the 3. That is, if you cut the cubes here of 1 centimeters, 1 centimeter edge, you get 3 cubes. So we have there 4 times 3. Then here, how many? We have 1, 2, 3, 4. So 4 times 6 plus 1, 2, 3, 4. So this one's included. So that is 4 times 4. How many cubes are they? That is 52 pieces of 1 centimeter cubes. So the correct answer is letter B, 52 pieces. So that is by visual inspection. Next we have number 6. Two equal spheres overlap such that the surface of one sphere passes the centroid of the other sphere. If the radius of each sphere is 2 meters, find the volume common to both spheres. Letter A, 10.47 cubic meter. Letter B, 14.07 cubic meters. Letter C, 17.04 cubic meters. Or letter D, 17.40 cubic meters. Okay? So, two spheres overlap, and then the surface passes the centroid of the other. So here we go. Two spheres, equal diameter. Then let's have the centroid here, centroid here. And we're looking for the volume common to both spheres. So we're looking at the volume of this portion here. Okay? So of course it's in 3D, it's volume. So imagine that. So how do we solve that? Well, we can solve that by getting they call this the zone. We call this portion here. I forgot how we call this. Okay, so if we get X here, so you get to solve this area here, this volume here, then times 2. And that's it. You get the volume. So I forgot the what do you call that part here? This portion here of the circle. Okay. So if we draw that, we draw the let's have it here. Right. Then this is the height of this is, if the radius of the sphere is 2 meters, therefore, so if this is 2 meters here, therefore this one here is 1 meter. And the volume is equal to pi h squared divided by 3 times 3r minus h. Okay, so let's have the volume. Let's put it here. So the volume of this one here is pi over h, pi times 1, should I say, squared divided by 3 times 3 times the r, radius of 2 meters minus 1. So the answer here, the volume here is 5 over 3 pi. And the total volume now is twice of 5 over 3 pi. That is equal to 10.47 cubic meters. Okay, so that is 10.47 cubic meters, and the answer here is letter A. Okay, that's for number 6. Next, let's go to number 7. A spherical wooden ball, 15 centimeters in diameter, sinks to a depth of 12 centimeters in a certain liquid. Find the area exposed above the liquid. Letter A, 45 pi square centimeters. B, 35 pi square centimeters. C, 54 pi square centimeters. And D, 43 pi square centimeters. Okay, so we have there the spherical ball, the spherical wooden ball. (15 centimeters in diameter), then it sinks to a depth of 12 centimeters. Therefore, the exposed height here is, so the exposed height is now equal to 3 centimeters. Then it's looking for the area of the exposed above the liquid, and the area for that is equal to 2 pi RH. That's the formula for that, the one exposed there at the top. So 2 pi RH, that is equal to 2 pi, radius is 7.5 times 3. So area is now equal to 45 pi square centimeters. So that's for number 7, and the answer here is letter A. Now let's go to number 8. The corners of a cubical box just touch the closed cylindrical shell that encloses it. The volume of the box is 27,000 cubic centimeters. What volume inside the shell is not occupied by the box? Letter A, 47,854.87 cubic centimeters. Letter B, 46,458.87 cubic centimeters. Letter C, 45,587.48 cubic centimeters. And letter D, 51,854.87 cubic centimeters. So let's have the drawing here. So that's the box inside a spherical shell. Now given is the volume of the box is equal to 27,000 cubic centimeters. Now if we name this as the side X, so we can definitely get the value of the X. So 27,000, and that is X raised to 3, right? For the volume of the cube. Therefore, X is equal to 30 centimeters. Okay? And if we want to get the value of the diagonal here, and that diagonal is also the diameter of the circle, we will just use Pythagorean theorem, d squared x squared plus x squared, that is d sub 1 squared is equal to 30 squared plus 30 squared. So d sub 1 here is equal to 30 square root of 2. Okay? So that is 30 square root of 2. So we now have here, so our target actually here is to find the volume of the sphere, and then we will find, subtract the volume of the box. But this is not the sorry, I need to be corrected. This is not the diameter of this is not yet the diameter of the circle. Why? Why is it that it's not the diameter of the circle? So this is the box. What happens is that we took the diameter or the diagonal here. This is the diagonal D1. And if the corner is touching the circle, that's not the diameter of the circle. Rather, the diameter of the circle is found here, from this corner towards this corner. Oops. And let's name that as the D, as the diameter. Now to find that diameter, knowing that this is X here, that is 30, we have the Pythagorean theorem, d squared equals the diagonal 1, so 30 square root of 2 squared plus the X, which is 30 centimeters. So D is equal to 30 square root of 3. Radius is equal to 15 square root of 3. So that we have here, the volume outside the box is equal to the volume of the sphere, 4/3 pi r cubed, minus the volume of the box, 27,000. So we have here 4/3 pi, the radius 15 square root of 3 raised to 3 minus 27,000. So volume outside the box is 46,458.87 cubic centimeters. And from the choices, that is letter B, 46,458.87 cubic centimeters. Okay. Now let's go to number 9. The sum of the radii, the sum of the radii of the bases of a frustum of a cone is 7 centimeters. If it has an altitude of 6 centimeters and a volume of 232.48 cubic centimeters, compute the radius of the smaller base. Is it letter A, 2 centimeters, B, 4 centimeters, C, 5 centimeters, or D, 3 centimeters? So let's have the drawing. We have here now the frustum of a cone. So we have two circular bases, the smaller one and the bigger one. Okay, what we're looking for is the radius of the smaller base, and that is R1. Now the condition here is that the sum of the radii of the bases of a cone is 7. So R1 plus R2 is equal to 7. So R2, R sub 2 is equal to 7 minus R sub 1. And then for the volume of the frustum of a cone, that is pi h over 3. That is R sub 1 squared plus R sub 2 squared plus R sub 1, R sub 2. Now, given the volume of the frustum of the cone as 232.48 cubic centimeters equals pi, the altitude is 6 divided by 3, radius 1 squared plus radius 2 is 7 minus R sub 1 squared plus R sub 1, then 7 minus R sub 1. So we have the 37 here because we already calculated that. So we have R1 squared plus 49 minus 14 R sub 1 plus R sub 1 squared plus 7 R sub 1 minus R sub 1 squared. So cancel R sub 1 squared here. So R sub 1 square minus 7 R sub 1 plus 12 is equal to 0. The roots here for this equation is, or the roots are 4 and 3. Now if we're looking for the smaller base, the radius of the smaller base, wherein if we add the radius, the radii, we get 7. Therefore, it's obvious that the radius that we are looking for is not 4, rather it is 3. So R sub 1 is 3 centimeters. So the answer for number 9 is letter D. Okay, let's go for number 10, the last problem. How many bricks are contained in a chimney in a shape of a frustum of a cone whose height is 18.30 meters, whose outer diameters are 1.2 meters and 2.4 meters respectively, and whose inner diameters are 1 meter and 2.20 meter respectively? There are 530 bricks to a cubic meter of chimney. So letter A, 5,790 pieces. B, 5,270 pieces. C, 5,290 pieces. Or D, 5,180 pieces. Okay. So how do we solve this? So a while ago, we were able to have the frustum of a cone, volume. And the volume of a frustum of a cone is pi h over 3 times r squared plus the bigger radius squared plus small radius, bigger radius. Then the given are, so let's put in the givens. So the inside diameter, the inside diameters are 1 meter and the outside diameter is 1.2 meter for the smaller diameters. Okay? And the bigger diameters, okay, Oops, we're running out of battery. So for the bigger diameters, we have here the inner diameter, bigger diameter, 2.20. The out, we have there 2.40. Since we are dealing with radius, let's have the radius radii. So 0.5. R out is equal to 0.6. Diameter in, radius in, should say radius in, 1.1. Radius out, and that is 1.2. Volume of the chimney is equal to volume out minus volume in. That is equal to pi 18.3 divided by 3. So we have here the out, volume out. 0.6 squared plus 1.2 squared plus 0.6 times 1.2 minus the volume in. 18.3 divided by 3. So we have 0.5 squared plus 1.1 squared plus 0.5 times 1.1. Okay. So that is equal to 9.77 cubic meters. So for the number of bricks, that is equal to 9.77 cubic meters. So let's put it here. And then says there we have 530 bricks in every 1 cubic meter. So cancel cubic meter here. So we have 5178.1 or approximately equal to 5180 pieces of bricks. And the answer here is letter D. That's for number 10. Okay, so that's all for this lecture video.